pleasant day to each and every one of us. I am Christhalen Fernandez, and in this video, we will be balancing a chemical equation. The chemical equation shown above can be read as mercury hydroxide reacts to phosphoric acid and produce the product of mercury 2 phosphate plus water or H2O. So let us first define what is a balanced chemical equation. A balanced chemical equation is one in which each of the side of the equation has the same number of atoms or ions of each element. Let us define or let us know what are the rules for balancing chemical equations. Number one, we have to write the chemical formulas for all of the reactants and the products. Number two, we have to write the formulas of the reactants on the left side of the reaction arrow and write the formulas of the product on the right side of the reaction arrow. Then, number three, let us count the total number of atoms or ions of each element in the reactants and the total number of atoms or ions of each element in the product side. Let us remember that a polyatomic ions that appears unchanged on both sides of the equation is counted as a single unit. Number four, let us balance the elements one at a time using coefficients. So a coefficient is a small whole number that is written in front of a chemical equation or of a chemical formula in a chemical equation. Then let us remember that we must not try to attempt to balance a chemical equation by changing the subscripts of the chemical formulas. We only have to change the coefficient but not the subscripts. So number 5, check each atoms or ions to be sure that the equation is correctly balanced. And number 6, finally, make sure that all of the coefficients are in the lowest possible whole number ratios. So at least one of the coefficient is a prime number. So after defining the rules in balancing chemical equation, let us proceed in balancing our given chemical equation. Let's go. So in balancing our chemical equation, already have done rule number 1 and rule number 2. We have written our chemical formulas. This is the product side, this is the reactant side, and this is the product side. So let us proceed to rule number 3. Let us count the total number of atoms or ions of each element in the reactant side and the product side. So we have our first element, the mercury, so Hg. So our Hg have one subscript, imaginary one if there's none, one subscript and one coefficient. So we have 1 times 1 is equal to 1. And then in our hydroxide, we have to separate the oxygen from hydrogen. So we have oxygen, this subscript will be distributed. So 2 times 1, 2 times 1 coefficient, 2 times 1 equals 2. And then in hydrogen, 2 times 1 is equal to 2. And let's proceed to our phosphoric acid. So we have 3 hydrogens, subscript 3 times 1 is equal to 3. And then we have our phosphate. Since it is not changed in our product side, we also have phosphate here, so we have written that as a single unit. So we have phosphate, 1 times 1 is equal to 1. And then on our product side, let's proceed to the product side. So our mercury in the product side, we have a subscript of 3, so we write this as 3 times 1 equals 3. And then our phosphate, we have 2 phosphates here, so 2 times 1 equals 2. And then we have in our next react to H2O or water, we have 2 hydrogens, so 2 times 1 is equal to. And then our oxygen, we have subscript 1 and then coefficient 1, so 1 times 1 is equal to 1. So let us look at our total number of ions or atoms. So in hydrogen and the product side, we have 1 in the reactant side we have 1, then 3 here. So it is not balanced. As we can see, it is not balanced. So let us proceed in balancing. We first have our mercury. Since our product side have 3 number of atoms or ions, so let's find a coefficient that will change this mercury to equal in the product side to the number of product side in this mercury element. So we've put 3 as a coefficient. So since that we have written 3 as our subscript for the Hg, we also have affected our hydroxide. So we will update our oxygen and hydrogen. So we now have 2 subscript of 2 times the 3 coefficient. So 2 times 3 is we have 6 oxygens, and then 2 times 3 we have 6 hydrogens. So let us look at our product side. On the reactant side, we have 6 oxygen. So in here, in our product side, we only have 1 oxygen. So let us change our coefficient. Let us look for a coefficient that will equal to 6 so that our oxygen will be balanced. So let us write 6 here as our coefficient to be equal to the total number of atoms on the reactant side. So we now have 1 times 6 is equal to 6 oxygen. So we now have a same number or balanced number of oxygen both sides. Let's proceed to since we have altered this, we have changed we have added a coefficient, so our hydrogen in the product side also changed. So we now have 2 times 6 equals 12 hydrogens. Let's proceed to our phosphate. So let us look at our phosphate. We have 2 phosphate on the product side and 1 phosphate on the reactant side. So let us look for a coefficient that will equal to 2 so that our phosphate will be balanced. So we have put 2 here so that we can have 2 phosphate. So 2 times 1 is equal to 2. We have balanced phosphate, 2 on the product side and 2 on the reactant side. Since we have put a coefficient 2 here, our oxygen will also our hydrogen will also change. So we now have 3 times 2 is equal to 6. So this 2 hydrogen, we will add this. This will equal to 12. So let us look at our product side. We also have 12 total numbers of atoms on the hydrogen. So in overall, let us check if our elements are balanced. On total number of mercury is 3, oxygen 6, same with the product side, hydrogen 12, and 12 product and reactant, and phosphate 2 and since the number of atoms and ions on both our reactant and product side are equal, this means that we have achieved our balanced chemical equation. So our final chemical equation, we now have 3 mercury 2 hydroxide reacts to 2 phosphoric acid produced 1 mercury 2 phosphate plus 6 water or 6H2O. So once again, this is Christhalen B. Fernandez. I hope that you have learned something in this video. Thank you and God bless.